Hi everyone, welcome to the 5th chapter of ArgoCD tutorial series, and in this chapter we are going to take a look at what are application sets and what are the various generators that it supports, and then we'll also dive into some of the various generators that we have in the application set, and we will deploy various applications into multiple Kubernetes clusters. So we'll also connect multiple Kubernetes clusters and then deploy the applications there. So let's get started. So you'll find all the resource materials for this particular chapter in this 03-application-set directory, and you can just clone it. It's a public repository. So let's first dive into what we have learned so far. So far we have learned all the basics of ArgoCD, like what are applications, how to deploy them, what are repo URLs, what is the destination, etc., how to configure them, what are the various sync policies, what are the various prune policies, etc. So far we have been building the foundations for our ArgoCD learning journey, right? But this is the chapter where it all binds together. So it is going to be a little bit longer video, but it is covering most of the advanced ArgoCD concepts as well. That's why it will be a little bit longer. So let's dive right in. So this is a sample application. This is what an application looks like. We have a source where we define the Git repository and the path from where we want to deploy, and a target or a destination, which Kubernetes cluster and a particular namespace. So I have talked about a pattern called application of applications pattern, where earlier you would have a single root application which would be responsible for deploying multiple general application, right? Now it was a little bit complex to set up, right? And that's why application set came into picture, and this is a relatively new object compared to the application object, and this basically is a replacement of application patterns, right? So it works in a very similar way. So what it does is, as you can see here, it is responsible for deploying multiple applications to multiple ArgoCD connected Kubernetes clusters, right? So for example, in this case, I'm using a list generator. I will talk about generators in detail in a little bit. So here I have 3 clusters: dev, QA, prod, and then I have an application called sample app manifest, and then I'm deploying that particular application to basically all these 3 clusters here. So this is very powerful because you don't have to now do those complex application of application patterns, etc., right? And this is baked in or built in to ArgoCD. So you just define everything in the application set, and then all your child applications will be created or deployed to the target Kubernetes clusters. So as mentioned earlier, we have something called generators in application set, and basically generators are very powerful, and they are responsible for generating parameters inside the template field of the application set resource. So we took a look at the application set, and this is a sample generator, and this is the template field, right? So whatever you see here, this will be dynamically populated based on whatever generator that you have used here, and then it will automatically be populated over here. So here you can see that the app name will be dev app, QA app, prod app, and then similarly it will be deployed to this particular cluster, this particular cluster, and this particular cluster, right? So that's what the responsibility of generator is. Now here it's a list generator. It's a very simple generator. Now let's dive a little bit deeper into the various types of generators. So we have close to 8 generators, as you can see on the right hand side of the screen. So in this tutorial we are going to cover the first 4th, because those are the most used or widely used generators. So let's dive into the list one. I think we have already seen this. It's straightforward. We have a key value pair defined in a list, and then it will be rendered inside the template field. Then we have something called a cluster generator. What you can do is you can define generator as clusters, and then if you do something like this, open curly braces and closed curly braces, it will pick up all the clusters defined in ArgoCD. So if you have to restrict it, you can just define kind of that specific cluster, whichever you want to deploy it to, just like we did in the list generator. So this is also very straightforward. And then we have something called Git Generator. This is mostly used in any environment where you have to scale and maintain your clusters list in Git as well, right? So in this case, you'll have something like a directory where you are maintaining all the clusters, and then from that particular YAML or JSON, all those clusters will be picked up and then populated into the templates field. So this is very powerful because you can get very granular here, and then based on that granularity, you can also make the template field also very granularized, right? We can have a lot more control, like selector labels, etc., where you can have a particular label, and then based on that label only a particular cluster will be chosen for an application to be deployed to. So we look at this Git Generator cluster in deeper detail when we do the hands-ons. So that's all about the Git Generator. And then the last one that I wanted to cover is the matrix generator. Now this, if you're saying this, it can be a little bit confusing, but this is also very powerful, because now you can combine two generators and then get the rendering in the templates field. So for example, here I am trying to combine the Git generator and the cluster generator. So here, as you can see, for example, this is the Git generator and this is the cluster generator. And if you combine this using a matrix generator, you will get an output like this. So now I can use this output and render the template like this here. So I can use all these four keys like path dot base name dot name, right, to populate the name field, etc., right? So we can get very creative using the matrix generator and then combine two generators and then populate the manifest or the template field. So now let's dive deeper into all these concepts that we just learned and then deploy a couple of application set to the Kubernetes cluster. So from the previous sections, you would have already seen that I have an ArgoCD cluster and I've deployed, some applications to this ArgoCD cluster already, right? And I've already gone ahead and configured my ingress, etc., to access the ArgoCD endpoint over the public internet. So if I just quickly log in, you'll be able to see this console over here. And if you go to clusters, right now I only have this in cluster. I don't have anything else. So in this section, what I'll do is I'll connect multiple Kubernetes clusters, and then I will also deploy the application set into those clusters. So let's do that. So I'll go over here and then I'll run a couple of commands. So first, I only have one cluster over here, but I'll go ahead and then create multiple Kubernetes clusters. So let me go ahead and first create a Kubernetes cluster called dev, and then in the US Central region, and I will enable workload identity here as well. Let me press enter. So this will take a couple of minutes. So I'll pause the video and restart once it's done. Awesome. So we have the dev cluster up and running. Now we'll do the same thing and create a staging cluster. Press enter. And this is again going to take a couple of minutes. So I'll again go ahead and pause the video and resume once it's done. Awesome. So we have both the clusters up and running. So if you go to the GKE console and hit refresh, we'll see that we have the dev and staging cluster up and running. Now, in order to deploy our applications to these two clusters, we have to first connect them to the ArgoCD cluster. So let's take a look at how to do that now. Let me expand this. Let me zoom in a little bit. Okay, so first we have to log in, and I have already gone ahead and installed the ArgoCD CLI. It's a very simple process. You just have to go to this installation section, and then if you are on Ubuntu, just copy these commands. If you are on Mac, just do brew install ArgoCD. It's straightforward. So in order to log in, I'll just copy this URL and then do ArgoCD login the URL. Okay, so username is admin, password is this, and now I'm logging in. So if I do ArgoCD clusters list, I'll see that there's only one cluster at the moment. So let's now go ahead and then connect the other two clusters as well. So in order to do that, first I'll have to get the credentials of these two clusters and then connect to it. So these are public clusters, so that's why I just have to do this. Otherwise I have to pass that -- internal IP flag, and then I'll also do it for the staging cluster. Okay, so now if I do kubectl config get context, I'll see all the 3 Kubernetes clusters contexts here. So let me go ahead and then rename some of these contexts just to make it a little bit easier to read. Okay, so that's done. Now if I do git context, I'll see that both are renamed. Now let me go ahead and then connect both of these clusters to ArgoCD now. So in order to do that, I have to run the ArgoCD cluster add command, and I have to pass the right cluster context. So if I do ArgoCD cluster add cluster context, let's pass staging and then name of the cluster, in this case staging, so and then yes. So it goes ahead and then creates the appropriate cluster roles, role bindings, the service account in the staging clusters, and then comes back with the output that the cluster is added. Now let me do the same thing for the dev cluster. Dev, and the cluster context is dev. So it does the same thing as the cluster role binding, and the service account in dev GK cluster, and then comes back with the output that the cluster is added. Now let me go ahead and then clear the screen and then run this command, ArgoCD cluster list. You'll see that now I should have 3 clusters in there. Now in order to deploy my applications to these 2 clusters, I have to just use these IP in my application set. But before I do that, let's first go ahead and then go to ArgoCD, and then here if I go to settings and then clusters, now here I can see 2 more clusters. So the status is still showing unknown, but once we deploy an application, it will be shown as successful. So in order to test this, let's first go ahead and then deploy a simple application. Let's call it simple app. Let's choose the project name as default, sync policy as automatic, self field prune. And if you want to take a look at all these options, what they do, etc., and learn more about them, look at the chapter 4 where I talk in depth about sync policies and prune propagation policies. Now repository URL is, let me choose this one, and here I'm still deploying a simple application just to test the connection to the cluster. So this is the directory. Let's choose this one. And then let's hit create. Now, as you can see that it started syncing, and then it will just go ahead and then deploy the application there because the sync policy is automatic. Now if I go to settings and then go to cluster, you'll see that the connection status is successful for dev. Same will happen for staging, but I'll not go ahead. This is just for demonstration purposes. I wanted to show you that the connection status will be unknown until unless you don't deploy an application. So this will go ahead and then sync it, deploy it, make it healthy, but I don't need it, so I'll just go ahead and then delete it. Great. Now let's go ahead and then look at the various application set generators that we have and then deploy it to these particular clusters. So in order to dive deeper, let's head over to the GitHub repo, and you can find the link of this GitHub repo in the description below. So we will look at the 03 folder, And then if we go under this, we will find multiple applications here. So let's start with something simple. So here you can see that I have an Nginx application, and then I have something called dev.yaml. So here you can see that I'm using a list generator, and I have the dev cluster and the staging cluster here. Now the IP of these clusters you can find from after going to settings, and then if you go to clusters, you'll see that these are the IPs of the dev and staging clusters. So that I have already updated, and then I'm updating the chart here. So here I'm using the Nginx ingress, and then the chart is ingress-nginx. I'm also deploying it in the ingress nginx namespace. So this namespace might or might not be present on the cluster already. That's why I have the sync options as create namespace equals true. So in order to know more about the sync policies and all those extra options that we have, refer the chapter 4, where I have talked about the sync policies, prune propagation policies, the various sync options in detail. So let's head over to the terminal here, and what I'll do is first I'll go ahead and clone this repo, and then we will deploy the dev.yaml that we just saw. Okay, it's cloned. If I go to ArgoCD Bootcamp and then head over to 03 ApplicationSet and then Nginx. So we have already looked at the contents of dev.yaml, and the expected behavior is once we deploy this, Nginx should be installed in the dev and staging. Now both of these clusters are fresh, so right now nothing has been installed in them, but after this Nginx should be installed in both the clusters. So what I'll do is first I'll check the context. So I have 3 clusters here, so that's why I have to make sure that I'm into the right context. So if I do kubectl config get contexts, I'm into the ArgoCD cluster context, which is great. So now let's go ahead and then deploy the dev.yaml. Great. So now if I head over to ArgoCD console, you'll see that ingress nginx is coming up for dev as well as staging. So it'll take a couple of minutes to come up, but until it is coming up, let's go ahead and then look at the ApplicationSet YAML in a little bit more detail. So if I go here, go to Nginx and this file that we just deployed. So here, as you can see that we are using the namespace as ArgoCD. Now this is the portion where, you know, an application set will be created in the ArgoCD namespace of the ArgoCD cluster, right? So if I quickly do kubectl get ApplicationSet -n ArgoCD. Now I'm running this command in the ArgoCD cluster where ArgoCD is installed. So here you can see that this came up just now, ingress-nginx, right? Now after that, we already talked about generators. Now I'm using the simplest one, which is list generator, and here it's just a key value pair. Cluster is dev, URL is this, cluster is staging, URL is this. And now I'm using these parameters in the template section. Now the first is the name, right? Now here I'm using ingress nginx. Now one thing to note here is you could have just done ingress-nginx, right? But the problem with that is, as we already talked about, that the generators helps in rendering the template to create the application. Now you can't create 2 applications with the same name, right? So that would have errored out after just deploying to any one of these cluster, most probably dev, right? So that's why we appended this hyphen cluster to make the application name unique. So if I just go here and do kubectl get application, you'll see that there will be 2 applications, ingress nginx dev and ingress nginx staging. And we all know that we can't have 2 duplicate names for the same object, right? So that's also very important to keep in mind. And the project that I'm using is the default project, and then the source that I'm using is ingress nginx repo. The chart is ingress nginx, and I'm using this particular version. And in the destination, I'm picking the destination from here. So one for dev and one for staging, and the namespace is ingress nginx. Sync policy is automated, and then I have mentioned create namespace is true, which means it will automatically go ahead and create this namespace and then deploy Nginx ingress. So the dev came up and the staging also came up, and if I quickly change the context to dev and show you that Nginx is installed or not, I will quickly do use context dev, and if I do kubectl get pods -n ingress Nginx, you'll see that this just came up now. The same will happen for staging as well, but I'll not show that. And let me again change the context to the ArgoCD cluster. Git contexts. Great. So now I'm back to the ArgoCD cluster context. Now let's dive deeper into some of the other generators. The first one on the list is Git Generator. And if I go to the ApplicationSet repository directory again and go to this train schedule, and here again you can see that it's a little bit similar to the earlier generator that we saw, which was the list generator. Now here we are using the Git generator, and what we are doing here is we are just putting a path to a file over here, and I'll show you what this file contains. But this file basically is a YAML which contains some of the values, like what is the cluster's URL, name, which application to deploy it, some of the selectors, label, etc. And then the repo URL is this one, and then I'm also using some match label selectors here. So if a workload will have deployed as the value, then only it will go ahead and then pick that particular application from the YAML and then deploy, right? And then the below section is pretty similar to the past. The only thing here is I'm not using a predefined Helm chat over here, but what I'm doing here is I'm creating an application of my own, and then I am using that application as a deployment. So let me head over to that application straight away. So this is a simple application, Node.js application, which just brings up a UI and shows a static train schedule. Now, as you can see here, this is the repo where the application is. Now, it is a best practice to segregate your application from the manifest files. Now, I have placed the manifest files of this particular application to a separate repo, which is this particular repo. So if I head over to this repo, and this is where you can find the manifest of this repo. But what it does basically is you will find multiple directory separated YAML files, because the images might change for each one of them. Now there are various approaches that you can take here, but I've taken this one for the demo, and it is nothing but a simple deployment and a service with a load balancer over here. Now everything is coming from a values.yaml, and here you can see that I'm using GCR. The image tag is this, replica count is 3, load balancer, and basically all the values are mentioned over here. I don't want to dive deeper into Helm and the directory structure over here, but it's a good practice to segregate the application repo from the manifest repo. So this is the manifest repo, and then I also have the manifest repo specified here, and then the path is this, which I just showed. And then the cluster name again .cluster.name will be picked up from that particular Git file. So let me go ahead and then show you the YAML for the cluster. So if I go here and dev gke.yaml, now here this server URL is of the dev cluster, and then these are my application to deploy. Now this is the label that I talked about. If I set this to not deployed or something else, then it will not match whatever is mentioned over here, and then it will not be deployed, right? So in this case, I will go ahead and then deploy the train schedule application. Now, one thing to note here is the deploy resources that I have just for demo purposes is a private repo. So you will not be able to deploy it without doing some kind of authentication, right? So ArgoCD will, complain about authentication issues. So let me quickly show you, that error. So I'm already here, and if I just do kubectl apply -f dev.yaml, and if I go to the ArgoCD page here, you'll see that it is coming up, but it shows me this authentication error, right? So now what I will quickly go ahead and then delete this. And what I'll do is I'll generate some keys over here. So I'll use ssh-keygen and press enter. And then it will ask for, the path, etc. I'll mention this and then the name of the key. No passphrase for now. And as you can see here that, the two keys were created. Now, if I head over to my GitHub, what I have to do is I have to go ahead and go to settings, and I have to come to SSH and GPG keys over here and add new SSH key. Now this key I already had from, way long. So I'll go here and add something like bootcamp -ssh-key. And then I'll choose as authentication key. And then here, if I go to pub section of this one, do Command C, and then I will just use this add SSH key. Now it will ask for my authentication code, so let me quickly complete all that process. And now the SSH key is added, which is this one. Now the public key is added here. Now if I go to ArgoCD and go to settings and repositories, I'll connect a repo and then I'll choose SSH. There are other options as well, but I'll choose SSH here. Name it Bootcamp. Project would be default. Repository URL, I'll choose my repository URL from here. And then I'll just go ahead and then copy this private key. Rest all I'll leave as default, and then the important thing is I'll save it as a credential template. Awesome. Now if I go to applications and move here, and then I do kubectl apply -f, oops, typo, dev.yaml, and head over to the ArgoCD console. Now here, as you can see that now it's coming up, and its service is coming up because it's a load balancer. The IP might take some time to come up, but this is what I wanted to show you in terms of how to connect a private repository from ArgoCD and then deploy it. So let's wait for this application to become healthy, and there it is. And I'll go to the dev cluster here. Again, I'll switch the context to use context dev, and if I do kubectl get pods, and I have to use the train schedule namespace because that's what we chose in our manifest, which is this one, and then we selected create namespace as true. So the 3 pods are up based on the specification. Let's look at this service as well. And here the service is this one, and if I go to this URL, hit enter, you'll see that the sample application should be up. And this is very simple application that I found from an Udemy course, and I just forked that repository. So kudos to the author. It's a shame I'm not able to remember the name of the author, but it was a very good Docker and Kubernetes course that I took, I think 6 years back. So kudos to them, and I just use this application in many of my demos, etc. So as you can see, there's a very simple application and it just works. So yeah, this is what I wanted to show you. Now I have the entire end-to-end pipeline as well, which I can show. So let's deploy entire pipeline. So suppose Hogwarts Express, there are some dependers on the way, and then it got late to maybe Sycamore station, right? So let's change that particular thing in the application. So if I go to the application again, this is my application, and I'll quickly do changes over here, and let's say the train is delayed. Okay, and I'll just copy this. Delayed arrival is maybe 12:10, and then delayed departure is 12:15. Great. So this is what we changed to, and then what we will do is commit the changes and then commit. So now this is again not an GitHub Actions course, but what I have is a bunch of GitHub Actions which are which is doing a simple build and push, and at the end of the push what it will do is it will just build the image and then update the train schedule deploy resources dev values.yaml and then change this particular thing over here. So it will take some time, so let's pause and for a moment. So this is in pending state, and let it first complete. So in the backend what it is doing is it is just building the Docker file based on this Docker file over here, very simple, and then it is just pushing it to Google Container Registry. So let's wait, and again I am not diving deeper into GitHub Actions over here, but this is what is happening in the backend, and I don't want to confuse you because this is ArgoCD Bootcamp and not GitHub Actions or Helm or Kubernetes Bootcamp. So that's why I'm not diving deeper into the backend of these other technologies. But let me know if you're interested to see GitHub Actions, Helm Bootcamp and GKE Bootcamp as well, just like this one. Great, so it's done. And if I move over here and quickly do a refresh, you'll see that just now a commit has been made. Now if I quickly go to GCP console and just type container registry and go over here, and you'll see that the train schedule application, the new image is also posted just a minute ago, and then this is the image tag ending with 03F, which was updated over here. Now once this is updated, we already have the sync policy as automated, and if I go over here and go to maybe train schedule here and quickly hit refresh, what it'll do is it will start syncing again. Now I've talked about this multiple times that why I hit refresh, because the default time is 3 minutes for ArgoCD to check the Git repo and match the desired state with the current state. So I don't want to wait 3 seconds for this demo. So that's why I went ahead and then clicked on that refresh, and since the sync policy was automated, it just went ahead and then it started the syncing process. So as you can see, it created a new replica set, and then it is doing a rolling update. So it brought up this new pod with the updated image, and then it is now deleting all the below images over here. Great, so the new replica set came up, and the earlier one, it will just go ahead and delete it. And if I go to my application again, and if I go to Hogwarts Express, it was showing on time, and if the changes would have picked them from the new images, it will show delayed, right? So yeah, this is the end-to-end pipeline. I know it's a lot to sink in, and a lot of things are happening in the background, but this is what I wanted to show, the power of ArgoCD coupled with GitHub Actions, Helm charts, and GKE. Great. Now that we have train schedule deployed in dev cluster, let's also deploy that in staging cluster. So I'll go to VS Code, and here, just like we have dev.yaml, I'll also create a new file called staging.yaml. And then I'll copy the contents from here and then paste them here. Now I'll change a couple of things here. So rather than dev GKE cluster, I'll call it staging GKE cluster, because that's where I want to deploy the train schedule application to. And also I mentioned that the name of the application should also be different. So here I mentioned train schedule, right? And I think in the previous chapter I mentioned that we have to change it. That's why we added this cluster parameter over here. So I'll just copy this and then add it in staging, otherwise I'll get the duplicate name, application name error, and this will not be spinned up. So now I'll also change this particular path, and then I think rest all looks good. Now why did I change that part? Because if I go to this particular repository and we see that I have the Helm charts for each and every environment, right? So we already looked at dev, where we updated the image and deployed, and similarly we have staging as well, where we have the image, and then we'll use that particular image to deploy the application. So that's great. Now let's do one thing, which is let's go to staging GKE cluster, from where the Git file will be pulled based on the generator that I have here, which is the Git generator. Now if I go here, I'll see that it's still that vanilla thing that I had from previous time. Now I'll have to update the server name as well. So if I go here and I'll fetch the server name from nginx.dev.yaml, and I have already updated it. And if I go here and paste this, now it's done. Now one thing you are seeing here is I have this train schedule deployed, which I'm using in the staging.yaml as a match label, and if I don't put this, the train schedule will not be deployed. And here you can also see that I'm creating the namespace in staging cluster. So if I quickly do git add and clusters, okay, now this is done. So now if I head over to this terminal over here and go to ArgoCD Bootcamp repo that I cloned earlier, and I've already done a git pull. So now let me move to 03 ApplicationSet directory and then train schedule. And just like I have provisioned the train schedule application in dev environment, I will similarly go ahead and then do a kubectl apply for staging environment. So as you can see, this is created. Now in the background, what is happening is the application set controller is coming into place, and then it is going ahead and then creating the application set, which in turn is creating the train schedule application. So if I have to check the logs, I could simply do kubectl get pods, and then I'll go ahead and then check the logs of the application set controller. So as you can see here, these are the logs, and it detected the train schedule staging and then spinned up that particular application. Now if I go over here, you'll see that staging is coming up. So this is how you can deploy your application into one environment and then take it to another environment. So I'll not wait for this to complete, but let me now switch over to another generator. And for that, I'll go to external secrets here and then go to dev.yaml. Now here you can see that I'm using the cluster generator, and then I'm using opening and closing curly braces over here. Now what this means is that this will deploy this particular chart, which is external secrets, which is used for storing secrets in a cloud provider secret management tool, and then it fetches into the Kubernetes cluster, right? So
Here it will deploy it into the in cluster where ArgoCD is installed, the dev cluster and the staging cluster. Now you can also go a little bit granular and then use match labels and then select a label which is assigned to your cluster. For example, staging equals to true, then it will only go ahead and then deploy to the staging cluster. Now for this example, I'll go ahead and then deploy external secrets to all the particular clusters. So if I head over to the terminal here now and clear the screen, and this time I'll go to external secrets and then let me do kubectl apply -f dev. Awesome. So this is also created, and if I'll go here, you'll see that 3 more applications are coming up: external secret dev, external secret in cluster where ArgoCD is installed, and then external cluster staging. Now this is what the cluster generator will do. Now I have another application where I'm using another method of Git Generator, but here you can see that rather than using something like this dev and staging.yaml as separate files to deploy to individual GKE clusters, so this one would be deploying to dev GKE cluster and this one would be deploying to staging GKE cluster. Here I'm using the Git Generator to deploy to both the clusters or whatever clusters which are mentioned in this particular clusters directory. In this case we have dev and staging. So this is what this particular thing is doing, and if I show you, this is a very simple application, and we are using local Helm here, and if I go to config, it just is deploying a echo server container or pod, right? And it's a very simple deployment which comes up with a replica of 3. But the main motive of this particular pattern that I wanted to show you is you can also be very creative with the Git Generator and then do something like this and match various regex and then do various match labels to deploy your applications. So if I head over to the terminal over here and go to echo server and do kubectl apply -f echo server.yaml, you'll see that that is also created. Now if I head over here, you'll see that the echo server staging and this echo server dev came up. Now these are all the applications that we deployed as part of this exercise. So you can see total of 9 applications here. So there was a lot of things to cover in this particular section. So we have deployed total of 9 applications as part of this chapter, and all of them are healthy here. I know it's a lot to digest and then sink in, so make sure you bookmark this particular chapter and revisit multiple times so that you digest all the concepts as well as these hands-on demos. So just to summarize, what we did was we just went through the concepts first of application set, then we looked into the various generators like list generator, cluster generator, Git generator, merge, matrix, etc. Right, all these generators, and then we started deploying the applications. So first we looked at the list generator and then we deployed Ingress Nginx staging and dev using the list generator, and then we deployed train schedule using the Git generator, and we also looked at the end-to-end pipeline of how to deploy your applications from changing the code to the GKE clusters, the entire end-to-end pipeline. And then we also deployed the train schedule application in staging by adding a new file called staging.yaml. And after that we used the cluster generator and deployed external secrets into local, staging and dev clusters, the entire clusters. And then we looked at the Git generator again, but there we were doing some kind of regex where we picked all the files in the clusters.yaml and then deployed the echo server there as well. So this is what we covered. I know this video has been a little bit longer, but it was a very important chapter to cover all together. So I hope you would have liked this video. So in the next chapter, I will cover ArgoCD hooks, sync waves, and how to optimize performance of ArgoCD. Until then, stay tuned and see you in the next chapter. Thank you.